Welcome back, deep divers. Today, we're serving up something special, a blend of business and tech as we explore the world of cloud architecting with AWS.
Ooh, sounds intriguing.
It is. Sometimes the best insights come from the most unexpected places, right? Well, today's journey actually starts in a bustling cafe owned by Frank and Martha, facing a classic challenge: growth.
Ah, yes, a good problem to have, but a problem nonetheless.
Exactly. And their daughter, Sophia, she's pretty tech savvy and sees how the cloud, specifically AWS, could really streamline their operations, manage inventory, process online orders, all that.
Smart move.
But here's the thing. Sophia doesn't have a deep technical background. So how does she even begin to approach this whole cloud thing? And it got me thinking, can anyone, even without being a coding whiz, really grasp the cloud and actually use it effectively?
That's a great question, and actually, it's the beauty of cloud computing. You don't need to be a tech guru to benefit. Even a basic understanding can empower you to make really informed decisions.
Okay, that's encouraging, but where do you even start? Our sources introduced these two AWS consultants, Olivia, a solutions architect, and Faith, a developer. They just happen to be regulars at the cafe. I love how those characters add a human touch to a topic that can feel really intimidating.
Yeah, it's like they're mentors, guiding Sophia through this sometimes confusing world of AWS. It highlights how important access to expertise can be, especially when you're just starting out.
Totally. I'm already picturing them, sketching diagrams on napkins, surrounded by coffee cups. But before we get lost in the caffeine haze, let's define what we're actually talking about when we say cloud architecting. Sometimes it feels like a buzzword.
It's more than a buzzword, though. It's really about taking all those cool cloud features we hear about, the instant scaling, rock-solid reliability, even potential cost savings, and applying them strategically to design a solution that fits the unique needs of a business.
So like a custom-built digital foundation for the cafe, not just slapping together any old tech.
Exactly. It makes me think of how AWS itself evolved. Even Amazon had to learn these lessons the hard way. Early on, as their e-commerce platform just exploded, they hit a wall. Their systems weren't designed for that level of growth. Things were messy, projects were slow.
Wait, so even Amazon struggled with this. That makes me feel a little better.
Right. It's a great reminder that everyone starts somewhere. What Amazon realized was they needed more organization, especially in their development processes. So they focused on creating really clear APIs, the interfaces that let different parts of a system talk to each other.
Ah, so even tech giants have growing pains. But that led them to create the resources we have today, right? Like the AWS well-architected framework, which comes up a lot in our sources. It's like an essential guide to building solid systems in the cloud.
Absolutely. Think of it as a blueprint with 6 pillars, each addressing a critical area. You've got security, reliability, performance, cost optimization, operational excellence, and even sustainability.
Wow, 6 pillars. They've thought of everything. But for the sake of our deep dive today, let's pick two that feel super relevant to a business like a cafe: security and reliability. After all, they're dealing with customer data and can't afford to have their systems crashing during the morning rush.
Makes sense. You hit the nail on the head. Security is paramount. And AWS operates on something called the shared responsibility model. Imagine it like this. AWS ensures the cafe building itself is secure. The walls, the locks, the foundation. But it's up to Sophia to handle security inside the cafe. Things like, locking the cash register, training staff on hygiene, making sure the Wi-Fi password is strong.
So it's a team effort, each side playing a specific role. And this is where the principle of least privilege comes in, right? It's mentioned a lot in the context of security.
Exactly. It's all about granting access only to what's absolutely needed. Think of it like giving the barista access to the espresso machine, but not to the accounting software or the cafe's bank account details. Each person or each system gets the bare minimum they need to do their job, limiting the potential for damage if something goes wrong.
Smart, like damage control, but on a digital level.
Yeah.
Now, what about reliability? How do we make sure this cloud-powered cafe can handle a sudden influx of customers, a power outage, or, I don't know, a rogue coffee bean grinder malfunction?
Well, one key principle is avoiding single points of failure. What AWS does is distribute your resources across multiple availability zones. These are like separate, self-sufficient data centers within a region.
Okay, so it's not putting all your eggs in one basket.
Exactly. It's
Yeah.
like having backup generators in case the main power goes out.
Yeah.
Even if one availability zone has an issue, your application can seamlessly switch over to another zone, keeping things running smoothly.
No more caffeine withdrawal-induced meltdowns. But let's get a little more specific. What are some of the core building blocks of this cloud-powered cafe? What's the engine under the hood, so to speak?
Okay. Imagine Amazon EC2, Elastic Compute Cloud, as the heart of it all. Think of it like, well, this is where those simplistic analogies break down. It's more nuanced than just virtual computers in a warehouse. It's about complete control over your computing resources, but in a way that's incredibly flexible and scalable.
Okay, fair enough. So it's not just about having virtual computers, but about being able to customize them to fit specific tasks.
Exactly. You choose the operating system, the processing power, the memory, the storage. It's like building a custom computer, but in the cloud. And this is where Amazon Machine Images, or AMIs, come in.
AMIs, those are like blueprints, right? I remember
Yeah.
seeing that term.
Think of them as pre-configured templates that save you from starting from scratch every time. Let's say Sophia needs a virtual computer to handle customer orders. Instead of manually configuring everything, she can choose an AMI that's already optimized for that task. It's like having a pre-built kitchen station for different types of orders, one for espresso drinks, one for pastries. You get the idea.
Okay, that makes way more sense. And I'm guessing there are different flavors of these virtual computers. Not all of them are created equal.
You're right. EC2 offers a variety of instance types, each suited for different workloads. You've got ones that are optimized for pure computing power, others that are focused on storage capacity, and some that are designed for memory-intensive applications.
So it's like choosing the right tool for the job. Not just any old hammer will do if you're trying to build a delicate pastry tower, right?
Precisely. That's the beauty of the cloud. You can tailor your infrastructure to meet the needs of your application without the limitations of physical hardware. Speaking of which, let's move on to something essential for any business storage. Where does our cloud-powered cafe keep all its valuable data? Customer orders, loyalty program details, even those top-secret recipes. Those secret recipes better be protected. That's where Amazon S3 comes in simple storage service. It's like having a massive, secure, and incredibly durable digital storage locker in the cloud, the pantry for all the cafe's digital ingredients.
So no more filing cabinets overflowing with paper receipts or external hard drives cluttering up the back office.
Exactly. S3 is designed for durability and scalability. You can store anything from website files and backups to massive data sets for big data analytics. And here's the kicker. It's incredibly cost-effective with different storage classes to match how frequently you need to access your data.
Hold on, storage classes.
Yeah,
Tell
right.
me more about those options. It's like choosing between different types of shelves in our digital pantry.
Yeah, think of it like this. You wouldn't store rarely used items, like last year's tax documents, on the most easily accessible shelf, right? You'd put them somewhere a bit more out of the way. In S3, that's what Glacier is for long-term archiving of data you access infrequently. And then you have Standard for frequently accessed data, and a bunch of options in between.
Okay, so the cafe's daily menu would be in standard, since it's accessed constantly, but their old employee records could be in Glacier.
Clever. But now I'm picturing Sophia trying to manage all this through some clunky interface, clicking buttons for hours. There's got to be a better way.
Oh, there is. It leads us to a concept that can seem complex at first, but it's all about making things easier in the long run. Infrastructure as code, or IIC.
Okay, code already makes me nervous. Am I going to need to learn a whole new language to understand this?
Not at all. It's more about the approach. Instead of manually clicking around to configure servers and storage, you use code to define everything. Imagine writing a digital blueprint for your entire cloud setup. So it's like having a set of instructions that automatically builds and configures the cloud infrastructure for the cafe. No more clicking through endless menus.
Exactly. AWS has a tool called CloudFormation. You write these templates, usually in JSON or YAML, that spell out all the resources you need, their configurations, how they connect. CloudFormation takes those instructions and builds it all for you.
Wow, that sounds powerful. But what happens if the cafe expands and needs to add more resources? Do we need to rewrite the entire blueprint?
That's the beauty of IAC. You simply modify the code, describe the changes you want, and CloudFormation updates the infrastructure accordingly. It's like having an architect who can instantly remodel your digital cafe based on updated blueprints.
This is incredible. I'm starting to see how this whole cloud thing can be so much more efficient than those traditional IT setups.
Mm-hmm.
But I have another question.
Mm.
What if the cafe decides to, separate its resources? Maybe they want a separate AWS account for customer data, another for their point of sale system, and so on. Wouldn't managing multiple accounts be a nightmare?
It could be, but AWS has a solution for that too.
Of course they do. What is it this time?
It's called AWS Organizations. Think of it as a central hub for managing multiple AWS accounts. It simplifies billing, security, and compliance, so Sophia doesn't need to juggle a dozen different logins.
So it's like having a master control panel for all those separate accounts.
Exactly. And within AWS organizations, you can use service control policies, or SCPs. They set boundaries on what actions can be performed in those accounts.
Wait, so it's not just about grouping the accounts together, but also controlling what can be done within each one.
Precisely. It's like giving each department its own set of keys, but with specific limitations. The marketing team might have access to social media tools, but not to the cafe's financial data.
Makes sense. It adds an extra layer of security even within that multi-account structure. But let's not forget about the data itself.
Sure.
We've talked about storing it, but what about managing and accessing it? What options does our cloud-powered cafe have for actually using the data?
That brings us to the world of databases, which is where things can get a little complex, but also really interesting.
Okay, databases. I know they're important, but I'll admit this is where my eyes usually start to glaze over.
Yeah.
Can you bring it back to our cafe scenario? How would they actually use databases in a practical way?
Okay, let's think about it this way. The cafe needs to keep track of customer orders, right?
Right.
And they need to store customer information for their loyalty program.
Yeah.
And of course, they need a place to keep Frank's famous cronut recipes safe and sound.
Uh-huh.
That's where databases come in. They're like the organized filing systems of the digital world.
Okay, that definitely makes it less abstract. But I kind of always assumed a database was just, well, a database. Like, are there different types of databases? I'm picturing like rows and columns of data. Is that even accurate anymore?
It's a good starting point, but it's not the whole picture. It's kind of like assuming all cafes are the same.
Oh, I see what you mean.
You've got your traditional coffee shops, your trendy tea houses, those cozy bakeries. Each one serves a purpose, right? Databases are similar. You need to choose the right type based on what you're storing and how you need to access it.
So no one-size-fits-all solution. I guess that makes sense. But how do you even know which database is the right fit? It feels like you need a computer science degree just to make that decision.
You don't need a degree, but you do need to think about what the data looks like and how it'll be used. For our cafe, they might need a relational database for structured data, like customer orders. Think names, order dates, items, prices, all neatly organized. But for something like customer reviews, which are more free-form text, a NoSQL database might be a better fit.
Okay, so relational for structured, NoSQL for unstructured. Got it. But what are some actual examples of these databases in AWS? Give me the menu, so to speak.
All right, so on the relational side, you've got Amazon RDS, Relational Database Service.
RDS.
It's like having a pre-configured database server where AWS handles all the technical maintenance, software updates, backups, all that. Sophia can choose from popular database engines like MySQL or PostgreSQL. Think of those as the different flavors of databases.
So no more late nights for Sophia troubleshooting database issues. She can focus on actually using the data to improve the cafe's operations.
Exactly. And RDS makes it easy to scale the database as the cafe grows. More customers, more data. No problem.
Yeah.
Now, on the NoSQL side, one of the popular choices is DynamoDB.
DynamoDB, okay.
This one's designed for speed and scale. Imagine thousands of customers accessing the cafe's loyalty program or placing online orders simultaneously. DynamoDB can handle that, no problem.
DynamoDB, it sounds powerful. But what kind of data would the cafe actually store in DynamoDB as opposed to RDS? Help me understand the difference in those use cases.
Think of data that doesn't fit neatly into rows and columns. Customer reviews, social media interactions, even real-time data from sensors in the cafe.
Sensors in the cafe.
Yeah, things like temperature or foot traffic patterns. That's where DynamoDB shines.
Okay, so structured data like organized spreadsheets, that's an RDS. And then the unstructured data, the messier stuff, but still valuable, that's DynamoDB. Got it. But how do we keep an eye on all of this? We've got these virtual computers running, data flowing in and out, services interacting with each other. It feels like we need a whole monitoring team just to make sure nothing catches fire, digitally speaking.
You're not wrong. Monitoring in the cloud is crucial. And AWS provides a tool called CloudWatch. Imagine it as this central dashboard that provides insights into the health and performance of your entire AWS environment. It's like having a set of sensors throughout the cafe, tracking everything from coffee consumption to customer wait times.
So CloudWatch is like the cafe manager's best friend, giving them real-time data and alerts if anything goes wrong.
Exactly. CloudWatch can track things like, CPU usage on your EC2 instances, the amount of storage you're using in S3, even custom metrics that you define. And the best part is you can set alarms.
Alarms, like a fire alarm for the cloud.
Kind of. Let's say the cafe's website suddenly starts experiencing a surge in traffic.
Oh, yeah.
CloudWatch can detect that spike and trigger an alarm, notifying Sophia so she can take action before it becomes a problem.
It's amazing. It's like having a safety net for your whole cloud infrastructure.
Mm.
But now I'm curious about this concept of elasticity that's mentioned in our sources.
Yeah.
How does the cloud actually handle those sudden bursts of activity, those moments when things go viral or a flash sale causes a stampede of online shoppers?
That's where the true magic of the cloud comes in. Remember how we talked about avoiding single points of failure?
Yeah.
Elasticity takes that a step further. It's about being able to dynamically adjust your resources based on demand.
Yeah.
Think of it like those extendable tables you see at banquet halls.
Oh, yeah, yeah.
You can add or remove sections as needed to accommodate more guests.
Right, right.
So during the morning rush, when everyone's craving their caffeine fix, the cloud can automatically spin up more resources to handle that increased traffic to the cafe's online ordering system. Then, during slower periods, it scales back down, saving on costs.
Exactly. It's like having a self-adjusting staff that automatically grows or shrinks based on how busy the cafe is.
You got it. One of the key tools for this is Amazon EC2 auto scaling. You define the scaling policies, essentially setting the rules for when to add or remove resources, and auto scaling takes care of the rest.
This is blowing my mind. It's like having this digital workforce that just adapts to the ebb and flow of demand. No more frantic calls to IT to add more servers or, the frustration of website crashes during peak hours.
And that ability to scale up or down on demand is one of the key advantages of using cloud computing. You can tailor your resources to precisely match your needs at any given moment without the constraints of that traditional infrastructure.
Okay, so we've covered a lot about building and managing this cloud-powered cafe, but I'm starting to realize we're not just building a digital version of a physical cafe. We're building something that can be so much more responsive, adaptable, and potentially even more efficient.
You're absolutely right, and that brings us to an important point about cloud architecting. It's not just about replicating what you already have in the physical world. It's about leveraging the unique capabilities of the cloud to create something truly innovative and transformative.
That's a great perspective. It's like instead of just building a digital storefront for the cafe, we're creating this whole new experience, leveraging data and technology to connect with customers in ways that wouldn't be possible in the physical world.
Exactly, and that's what makes cloud architecting so exciting. It's about pushing the boundaries of what's possible and using technology to create truly innovative solutions.
Okay, I'm feeling inspired, but I also realize we haven't even scratched the surface of what's possible with AWS. Well, what are some other areas we should be thinking about as we build out our cloud-powered cafe?
Well, one area we haven't discussed yet is content delivery. Imagine the cafe wants to share, their latte art tutorials online or offer virtual barista training sessions.
Ooh, that's a good idea.
They need a way to deliver that content to a global audience quickly and reliably.
Okay, content delivery. Is that where those edge locations come in? I remember seeing that term in our sources, but wasn't entirely sure what it meant.
You're on the right track. Think of edge locations as like mini data centers scattered all over the world.
Oh, okay.
They're closer to your users. Instead of all the website traffic having to travel back to the main data center, which could be thousands of miles away, it can be served from an edge location that's much closer to the user.
So it's like having pop-up cafes all over the globe, serving up digital content with lightning speed.
That's a great analogy. And AWS has a service called CloudFront that makes this easy to implement. It's a content delivery network, or CDN, that leverages those edge locations to cache content like images, videos, even entire web pages, so they load faster for users no matter where they are.
This is brilliant. So if someone in Paris wants to watch the cafe's latte art tutorials, they're not waiting for the video to bucker while the data travels across the Atlantic. They're getting a seamless, high-quality experience.
Exactly. CloudFront is a game changer for businesses with a global audience. And it's just one example of how AWS services can be used to enhance the customer experience and reach new markets.
This is incredible, but I'm also starting to realize that with all these interconnected services and vast amounts of data, security becomes even more critical.
Yeah.
We can't just put a padlock on the digital door and call it a day.
You're absolutely right. Security in the cloud is a multi-layered approach. And it starts with managing access and permissions. We touched on the principle of least privilege earlier, and that's a key concept here as well.
Okay, back to giving the barista access to the espresso machine, but not the accounting software. Got it. But how do we actually implement that in the cloud? Are we talking about digital locks and key cards?
Not quite. but AWS does provide a powerful service called IAM Identity and Access Management. Think of it as a central control panel for managing who has access to what in your AWS environment.
So it's like a digital bouncer checking IDs at the door of our cloud-powered cafe.
Exactly. With IAM, you can create users, groups, and roles, and then assign specific permissions to them. It's granular control. So you can determine who can access which services, which resources within those services, even what actions they can perform.
Okay, so I could create a barista role
Yeah.
that has permission to use the point-of-sale system, but not access customer data.
Right?
And I could create a manager role with more extensive permissions.
Ah,
It's all starting to click now.
you got it. And IAM goes beyond just managing users. It also plays a key role in securing application access to AWS services. Remember how we talked about the cafe's online ordering app?
Yeah.
Well, that app needs to interact with AWS services to process orders, update inventory, and so on. But we wouldn't want to give it permanent access keys that could potentially be compromised.
Right, that would be like giving out a master key to the entire cafe. Not a good idea. So how do we give the app the access it needs without compromising security?
That's where IAM roles come in. Think of them as temporary access badges that expire after a set period.
Oh, okay.
The online ordering app can assume a role that grants it the specific permissions it needs to perform its tasks, but those permissions are limited and time-bound.
Okay, so it's like giving the app a temporary access code that only works for a specific task and then expires. That makes a lot of sense from a security standpoint. But what about the data itself? We're storing all this sensitive customer information, financial records, even those secret recipes. How do we make sure it's protected from hackers and cybercriminals? It feels like we need a digital vault.
You're thinking along the right lines. That's where a service called AWS KMS comes in, Key Management Service. Think of it as a secure vault for your encryption keys.
Encryption keys, those are the things that like scramble the data so it's unreadable without the proper code.
Exactly. Instead of trying to hide your encryption keys under a virtual mattress, you store them securely in KMS. You control who has access to those keys, and you can even rotate them regularly for added security.
So even if someone manages to break into our cloud-powered cafe, they won't be able to make sense of the data without the encryption keys, which are safely locked away in KMS.
Precisely. And KMS integrates seamlessly with other AWS services, so you can easily encrypt your data at rest, in transit, and even while it's being processed. It's like having a comprehensive security system for your data with multiple layers of protection.
Okay, I'm feeling much better about the security of our cloud-powered cafe now.
Yeah.
What about those moments when things go wrong?
Hmm.
How do we troubleshoot issues, track down errors, and make sure everything's running smoothly? It feels like we need a digital detective on call.
Well, remember our friend CloudWatch?
Yeah.
It's not just for monitoring. It also plays a key role in logging.
Logging, as in keeping track of everything that's happening in our AWS environment.
Exactly. You can configure your AWS services to send their logs to CloudWatch logs, where you can centralize, store, and analyze them. It's like having a detailed record of all the activity in your cloud-powered cafe. You can search, filter, and analyze those logs to identify issues, troubleshoot problems, and even detect security threats.
So if the cafe's online ordering system starts acting up, we can dig into the logs and see what's causing the problem. No more guessing games.
Precisely. CloudWatch Logs is an invaluable tool for understanding what's happening in your AWS environment and resolving issues quickly and efficiently.
This is incredible. We've covered so much ground already, from basic building blocks like EC2 and S3 to more advanced concepts like IAM and KMS. It's clear that security is a top priority in AWS, and there are tools and services available to address every aspect of it.
And that's just scratching the surface. We haven't even touched on some of the more cutting-edge areas like serverless computing and containers.
Wait, serverless? As in no servers at all? How does that even work?
It's a revolutionary approach to building and running applications without having to manage servers. It's all about focusing on the code and letting the cloud provider handle the underlying infrastructure.
Okay, I'm intrigued, but also a little confused. Can you give me a real-world example of how this serverless thing would apply to our cafe?
Imagine the cafe wants to build a new feature that automatically sends a personalized greeting to customers when they connect to the cafe's Wi-Fi.
Oh, okay.
Instead of setting up and managing a whole server for this, they could use a service called AWS Lambda.
AWS Lambda, that name rings a bell. It was mentioned in our sources.
Exactly. Think of Lambda as a function as a service platform. You write your code, package it as a Lambda function, and then configure it to be triggered by specific events. In this case, the event would be a customer connecting to the Wi-Fi.
So when the customer connects, the Lambda function springs into action, grabs their name from the loyalty program database, and sends them a personalized welcome message, all without us having to manage any servers.
You got it. And we only pay for the compute time that the function uses, which can be fractions of a second. It's incredibly efficient and cost-effective.
This is blowing my mind again. But what happens when we have more complex workflows? Not just a single function, but a series of steps that need to happen in a specific order.
Yeah.
Like maybe the cafe wants to add a feature where after a customer places an online order, it automatically updates inventory, sends a notification to the barista, and charges the customer's credit card.
That's where AWS Step Functions comes in. Imagine it as a visual workflow designer for serverless applications. You can define a series of steps, each one potentially triggering a Lambda function or other AWS services, and Step Functions orchestrates the whole process.
So it's like a recipe for our cloud application.
Yes.
We define the ingredients, the Lambda functions, and other services, the steps, the order they need to execute.
Mhm.
And step functions is like the chef who orchestrates that whole cooking process.
That's a great way to put it. Step Functions allows you to build complex, serverless workflows that can handle all sorts of tasks, from processing data to interacting with other AWS services.
This is incredible. I feel like we're moving beyond just managing servers and
Yeah.
into this whole new world of automation and orchestration. But I have to ask, what about those applications that can't be completely serverless? Maybe they have special software requirements or need more customized environment. Do we have to go back to managing servers for those?
That's where containers come in. Think of containers as lightweight, self-contained packages that hold everything an application needs to run. The code, the libraries, the dependencies, everything.
Okay, so it's like shipping our cafe's secret cronut recipe in a special box, along with all the ingredients and instructions, ensuring it can be recreated perfectly anywhere in the world.
That's a fantastic analogy. Containers provide portability and consistency, allowing you to run your applications in various environments, from your own servers to virtual machines, and yes, even on serverless platforms.
This is getting really interesting. But how does AWS support this whole container thing? Do they provide the special boxes?
You bet they do. AWS has a suite of services for building, deploying, and managing containerized applications.
Okay, break it down for me. What are the key services involved?
One of the core services is Amazon Elastic Container Registry, or ECR. It's a fully managed container registry where you can store and share your container images. Think of it like a digital pantry for your containerized recipes, ready to be deployed whenever and wherever you need them.
So we store our containerized apps in ECR, but where do we actually run them? Do we need to build our own container farm?
Not at all. AWS offers two main services for running containers: Amazon Elastic Container Service, or ECS, and Amazon Elastic Kubernetes Service, or EKS.
Okay, two options, ECS and EKS. What's the difference? So both sound pretty technical.
ECS is the simpler of the two. It's a fully managed container orchestration service that makes it easy to deploy and manage containers on AWS. Think of it like having a sous chef who's really good at following your containerized recipes. Now, EKS is a bit more advanced. It's based on Kubernetes, which is an open source system for managing and scaling containerized applications.
Kubernetes, that name sounds familiar. It's like the big leagues of container orchestration, right?
Exactly. It's incredibly powerful, but also more complex to manage. EKS makes it easier by providing a managed Kubernetes service on AWS, giving you the best of both worlds: the power of Kubernetes with the ease of management provided by AWS.
So if ECS is like having a sous chef who's great at following instructions, then EKS is like having a master chef who can orchestrate an entire kitchen, handling those complex culinary creations with precision and finesse.
That's a perfect analogy. The choice between ECS and EKS really depends on the complexity of your applications and how much control you need over the underlying infrastructure.
It's incredible. We've explored serverless computing, containers, and even touched on the world of Kubernetes. It's clear that AWS offers just this mind-boggling array of options for building and running applications in the cloud.
Yeah.
But it's also a lot to take in. What advice would you give someone who's just starting out on their cloud journey? Where do they even begin?
One of the best things you can do is familiarize yourself with the AWS well-architected framework. We talked about its 6 pillars earlier, and it's an invaluable resource for understanding best practices for building secure, reliable, and efficient systems in the cloud.
Right, the 6 pillars: security, reliability, performance, cost optimization, operational excellence, and sustainability. It's like having a checklist to make sure you're covering all the bases as you build out your cloud infrastructure.
Exactly. The well-architected framework provides a framework for thinking about your cloud architecture and ensuring that you're considering all the critical aspects from the start.
So it's not just about knowing which services to use, but also about understanding how to use them in a way that's secure, efficient, and scalable. It's like having a blueprint for building a successful cloud-powered cafe.
Precisely. And as you gain experience with AWS, you'll start to develop your own best practices and architectural patterns that fit your specific needs and use cases.
Okay, so we've got our blueprint, we're building out our cloud cafe, we're thinking about security, scalability, and all these other important factors. But what about those moments when things go unexpectedly viral? Like what if our cafe suddenly gets featured on, I don't know, a popular food blog and thousands of people try to access the website at the same time?
Yeah.
Can our cloud infrastructure handle that kind of surge in traffic?
That's a great question. And it brings us to the concept of load balancing. Imagine you have a single barista trying to serve hundreds of customers at once.
Uh-oh.
Chaos, right? Load balancing is about distributing that traffic across multiple servers, preventing any single server from becoming overwhelmed.
So it's like having multiple baristas on hand to handle the rush, making sure that no one has to wait too long for their caffeine fix.
Exactly. AWS offers a service called Elastic Load Balancing, or ELB, that provides a variety of options to fit different needs.
Okay, so we're talking about different types of load balancers. What are the options on the menu?
You've got three main types: application load balancers, network load balancers, and classic load balancers. Each one has its own strengths and is suited for different use cases.
Okay, I'm ready for a load balancer breakdown. Give me the details.
Okay, application load balancers, as the name suggests, operate at the application layer.
Okay.
They're smart enough to make routing decisions based on the content of the traffic. Let's say the cafe's website has separate sections for online ordering, loyalty programs, and catering requests. An application load balancer can route traffic to the appropriate backend server based on the URL, ensuring that each request goes to the right place.
So it's like having a digital traffic cop, directing customers to the right department based on their needs.
Exactly. Now, network load balancers are more focused on raw performance. They operate at the transport layer, handling massive amounts of traffic with low latency. They're a good choice for applications that need high throughput and speed, like gaming servers or video streaming platforms.
Okay, so if the cafe decides to live stream their latte art competition, a network load balancer would be the way to go. But what about the old school classic load balancers? Are those still relevant?
They are still supported, but AWS recommends using application or network load balancers for new deployments whenever possible. Think of classic load balancers like our trusty old coffee grinder, still functional, but maybe not as efficient as the newer models.
Makes sense. So we've got load balancing covered, which is essential for handling those spikes in traffic. But what happens when our cafe goes global? Let's say they open a location in Paris, and they need to ensure a seamless experience for customers in Europe. How do we manage traffic across different geographic regions?
That's where a service called Amazon Route 53 comes into play.
Route 53.
Route 53 is a highly available and scalable DNS service.
DNS, as in domain name system, the thing that translates like human-readable website names into those numerical IP addresses.
Exactly. Route 53 allows you to manage your DNS records and configure various routing policies to control how traffic is directed to your applications and resources.
Okay, but how does that help with global traffic management?
Route 53 supports a feature called geolocation routing.
Geolocation routing.
This allows you to route traffic to different endpoints based on the user's geographic location.
Oh,
So if a customer in Paris tries to access the cafe's website, Route 53 can route them to the servers in Europe, ensuring a faster and more responsive experience. Meanwhile, a customer in New York would be routed to the servers in North America.
so it's like having a virtual concierge who directs customers to the nearest cafe location based on their current location. That's brilliant. It ensures that no matter where customers are in the world, they're getting the best possible experience.
Exactly. Route 53 is a powerful tool for building global applications that can handle traffic from all over the world. But there's another level to this global resilience: multi-region architectures.
Okay, multi-region. I'm guessing this is about taking things a step further and not just distributing traffic within a region, but across multiple regions. But why would you do that? Isn't that overkill?
It might seem like overkill, but imagine this. What if an entire AWS region experiences a major outage? It's rare, but it can happen. By deploying your application across multiple regions, you create redundancy.
So it's like having backup cafes in different cities, ensuring we can still serve customers even if one location is temporarily unavailable.
Precisely. Multi-region architectures provide the highest level of availability and fault tolerance. It's not always necessary, but for mission-critical applications, it can be worth the added complexity and cost.
It's incredible. We've gone from basic building blocks to global traffic management and disaster recovery. It's clear that AWS has thought of everything when it comes to building resilient and scalable cloud infrastructure. But with all these options, it also feels like it could get really expensive really fast. How do we make sure our cloud-powered cafe doesn't end up bankrupting Frank and Martha?
That's a great question, and it brings us to a topic that's often overlooked in the excitement of cloud adoption: cost management.
Okay, cost management. It's like the less glamorous side of running a business,
Mm.
but obviously it's crucial. What are some key things to keep in mind when it comes to managing cloud costs?
It's like even if you never bake a cake yourself, knowing the basic ingredients and techniques helps you appreciate a good pastry chef even more.
Right.
You can ask better questions, make more informed choices.
Exactly. It's about becoming a more informed consumer of technology. You don't need to know how to build a database from scratch, but understanding what databases are and how they're used helps you make better decisions about the tools and services you use, maybe in your own work even.
Precisely. And that's especially important, I think, in today's world where technology is so deeply intertwined with everything we do.
Couldn't agree more. Okay, one last thing before we sign off. We've talked about all the cool things you can do with AWS, but let's be realistic. It's not free. How do we make sure our cloud-powered cafe doesn't end up with a bill that's bigger than their monthly rent?
Cost management is absolutely crucial, and it's something you need to be thinking about from the very beginning of your cloud journey. Fortunately, AWS provides a lot of tools and resources to help you stay on track.
Okay, give me the highlights. What are the top tips for keeping those cloud costs under control?
One of the most fundamental things is to take advantage of that pay-as-you-go model. You only pay for the resources you actually use, and you can scale up or down as needed.
So no more paying for a full month of server capacity when you only need it for a few hours a day.
Exactly. That flexibility is a huge advantage of the cloud, but it also means you need to be diligent about monitoring your usage and making sure you're not leaving resources running unnecessarily.
Right, it's like leaving the oven on all day when you only needed it to bake a batch of cookies.
Mm.
Waste of energy and money. So how do we avoid those, like digital energy vampires?
AWS offers a service called Cost Explorer. It gives you really detailed insights into your spending patterns. You can view costs by service, by region, by time period, and you can even tag your resources to track costs by department or project.
So it's like having itemized receipts for all your cloud activity. You can see exactly where your money's going.
Precisely. And you can set up alerts to notify you if your spending exceeds a certain threshold.
Ooh, that's a good feature. I can imagine that being helpful for catching those unexpected spikes in usage before they turn into a major budget problem.
Hmm.
But what about those scenarios where you have more predictable workloads? Let's say our cafe knows it needs a certain amount of computing power for its online ordering system 24/7. Is there a way to get a better deal on those resources?
Absolutely. That's where reserved instances come in.
Reserved instances, okay.
It's like signing a lease for your cloud resources instead of renting them on a month-to-month basis.
Oh,
You commit to using those resources for a longer term, usually 1 to 3 years, and in exchange, you get a significant discount.
okay, so it's a trade-off between flexibility and cost savings. Reserved instances are great if you have those predictable workloads, but on-demand pricing makes more sense if your needs are more variable. But are there any other cost-saving options besides reserved instances?
Yeah. AWS offers a variety of other pricing models, like savings plans, which provide discounts for consistent usage across multiple services, and even spot instances, which allow you to bid on spare EC2 capacity at a much lower price. It's like getting a last-minute deal on a plane ticket.
Wow, so many options to optimize your cloud spending. It's clear that cost management is not an afterthought in AWS, but rather an integral part of the cloud journey.
Absolutely. And as you gain more experience with AWS, you'll develop your own cost optimization strategies and best practices.
This has been an incredible deep dive. We've gone from picturing a simple cafe to exploring this vast landscape of cloud services, security measures, scaling techniques, global traffic management, cost optimization strategies, even those cutting-edge concepts like serverless computing and containers. It's clear that AWS is much more than just like a collection of tech tools. It's a platform for innovation and transformation.
I couldn't agree more. The cloud has the power to revolutionize the way we do business, the way we work, and even the way we live. And AWS is at the forefront of this digital revolution.
Well said. And on that inspiring note, we'd like to thank you for joining us on this deep dive into the world of cloud architecting with AWS. We hope you found it insightful, engaging, and maybe even a little bit mind-blowing.
And remember, the cloud journey is just beginning. There's always something new to learn, something new to explore.
Absolutely. So keep that curiosity alive, keep experimenting, and keep pushing the boundaries of what's possible with AWS.
And be sure to check out the show notes for links to all the resources that we mentioned today.
Until next time, happy cloud adventures.